Now, we've previously run this engine for a little bit of time to warm it up, too. To run the engine for a little additional time, and our meter's starting to come up now, so I think our O2 sensor is warm enough, and it does have to be at least 600 degrees Fahrenheit for this test to work.
Now I'm going to go ahead and open up the vacuum port, and we should watch the numbers drop as we wean the mixture.
Yep, going way down. Put your finger over it, plug the vacuum leak, numbers go back up. Way down, and back up.
Now, as you can see, the engine almost stalled on this test, and on some vehicles it actually would stall. So on those vehicles, we'll have to do something called a propane enrichment test.
Sure.
And so I'm going to take this valve, which we have screwed to a propane bottle. It's a regular propane bottle with a special valve on it for doing this test, and connect it to the vacuum port.
Okay, now we have a slight vacuum leak introduced, so we're seeing a real low voltage on the voltmeter, which is a signal of a lean mixture. Now, if we open the propane bottle up, our reading should go up. There it goes, way up.
And as I shut it off, it goes back down.
Way back down.
But this gives us the opportunity then to test an O2 sensor on the vehicle with either a vacuum leak or a propane enrichment test.
Let's review the test procedure for an oxygen sensor that has been removed from the vehicle. The first step is to remove and inspect the oxygen sensor. Set the digital voltmeter, or DVOM, to the 2-volt scale. Connect the DVOM red lead to the black wire of the O2 sensor and the black DVOM lead to the oxygen sensor outer shell. Heat the sensor tip in a torch flame. The voltage should exceed 0.9 volts in less than 1 minute. Remove the sensor tip from the flame. The meter reading should reach 0.1 volts or below within 3 seconds. Now let's review the test procedure for an oxygen sensor that's still installed on the vehicle. Connect the voltmeter leads to the oxygen sensor lead and a good ground. Locate a manifold vacuum port or source. Start and run the engine until the meter readings start to vary or toggle. Create a vacuum leak at the port or source located earlier. Observe the meter reading. The voltage reading should fall below 0.1 volts with a vacuum leak and rise above 0.5 volts when the vacuum leak is plugged.
The tools you will need to replace your oxygen sensor include a 3/8 drive socket set, a special oxygen sensor socket, and a torque wrench. In some cases, you may also need a soldering gun and solder, a wire crimping tool, and some heat shrinkable tubing and a cigarette lighter or source of heat. And in all instances, you'll need the correct new oxygen sensor for your vehicle.
The first step in replacing your oxygen sensor is to start with a cool engine. Then locate the sensor and clip off the existing wire or wires near the sensor itself. With a socket of the correct size, remove the old sensor from the exhaust manifold. For ease of removal, you may want to use a special oxygen sensor removal socket as shown. Place a small dab of non-volatile anti-seize compound on the threads of the new oxygen sensor. Install the new sensor in the threads, starting it by hand, and tighten to recommended specifications. Install a piece of heat shrink tubing over the wires, and reconnect the wires to the new sensor with the crimper and butt-type wire connector. We suggest soldering this connection with rosin core solder for a positive corrosion-free connection. For wiring details on your particular vehicle, consult the complete wiring instructions included with your new NAMCCO oxygen sensor. Then slide the heat shrink tubing over the connection and collapse the tubing with a heat gun or lighter until it shrinks and weather seals the connection. That's all there is to replacing the oxygen sensor in your computer-equipped vehicle.
Now let's review the steps involved in replacing an oxygen sensor. First, cut the wire lead for the oxygen sensor. Then, remove the sensor from the exhaust manifold or pipe. Next, apply an anti-seize compound to the threads of the new sensor. Install the new sensor and torque to specifications. Lastly, reconnect the electrical lead by soldering and using a heat shrink insulator.